Alright, so this is a lot of information and I'm going to go through it from left to right. Okay, so the inverse trig functions we all know as sine inverse, cosine inverse, tangent inverse, all the way down. But I like to use the terms arc sine, arc cosine, arc tangent, just because that's what a lot of old school computer work actually does. Okay, so identities involving inverse trig functions. Now, if you have the arc cosine of x plus the arc cosine of negative x of the negative angle, you get pi, or you could do the reverse, which is the arc cosine of the negative angle is equal to pi minus arc cosine of that angle. Okay, now arc sine of x plus arc cosine of x is actually going to be pi halves. And that's going to be huge later because we can actually come up with some what is called cofunction identities. Okay, so now if we take a look at this, here's all the derivatives, and they are derived pretty straightforward in the book and stuff, but here's just the formulas of what you need to know. Okay, and just for your information, if we copy, control copy, okay, okay. Alright, the derivative of arc sine of x is going to be 1 over the square root of 1 minus x squared, where the absolute value of x is less than 1. Okay, and the derivative of arc tangent of x is going to be 1 over the same thing, but without the square root, and there's a plus sign between them. Okay, and that derivative of arc secant of x is going to be 1 over the absolute value of x times the square root of x squared minus 1. Okay, and so that's all set up. And these are the first three defined. And because of inverse trig cofunctions, where arc cosine of x is equal to pi halves minus arc sine of x, same thing with arc cotangent and arc cosecant, we can actually come up with the formulas for this. And to be honest, the only difference is, you guys, is that they're actually the negative versions of their counterparts, of their negative counterparts, cofunctions in the inverse realm. Okay, so these are all the derivatives, and just working with them, you just need to take your time. Just be very careful when working with it and use these formulas to your best extent, okay? Okay, so let's take a look at this bad boy. What does this actually equal? Okay, first off, this is going to be a chain rule type of function, so we're going to have that all set up. Okay. Alright, but most importantly, it's just going to be set up as the arc secant. So the arc secant is going to be the one on top, and then we're going to have the absolute value of 3x cubed times in front. Okay, then we're going to times by the square root of, well, this should be 9x to the 6th minus 1. Because we're actually squaring that entire part down there. Okay. Now, what we're going to be timesing by is the derivative of the inside function, which is going to be 9x squared. Okay. All right. Now, what we can do is we can get rid of this 1 up here because we're already multiplying it by there. We can get rid of this times, and this just is replaced as 9x squared over the absolute value of 3x cubed times the square root of 9x to the 6th minus 1. Now you can actually simplify both of these parts right here, okay, so that we can actually turn this out to be equal to 3 on the top then absolute value of x times the square root of 9x to the 6th minus 1. And you can have that in parentheses. I would definitely make sure you put that in the calculator in parentheses. Alright, now if you ended up with an even power in here, you could get rid of the absolute value because it's unnecessary, because whenever you square something. But if you have an odd, you're definitely going to have the absolute value right there. Okay? Alright, so there's some examples of actually working with this, and they, pretty much all of them, the chain rule is going to work a lot like what we just did, okay? Alright, that's it for derivatives with inverse trig functions, part 1. I'll talk to you later.